Hi everyone, I'm Navya studying from Mahindra Hills, TSWREIS, COE Mahindra Hills. Before going to introduce my topic, I would like to show you the most mysterious and the prehistoric megalith which is located in Scotland, and that is Stonehenge. Here you can see the Stonehenge, and lots of researchers have gone into it. Many researchers have gone into it. And you can see the four Saxon stones are placed perpendicular to the ground and they are parallel to each other. So when we cut it diagonally, there forms two right angle triangles. So there forms 5:12:13 Pythagorean triangle. So this is the most mysterious place as we know. So let's move to another slide. Here you can see Egyptian pyramids, one of the 7 wonders of the world. And one theory about the construction of this involves use of special right triangles. And during Pythagoras, a famous mathematician, when he had a trip to Egypt, he noticed that the people of those places had an interesting strategy. What they did was, they have used 12 knotted rope, which is evenly spaced, and it forms a perfect 5:12, 3:4:5 triangle. And let's move to another slide. Here you can see Chichen Itza, one of the 7 wonders of the world. And this Kukulkan Mayan pyramid, this is the Kukulkan Mayan pyramid. You can see over here. So this pyramid, this is actually a square pyramid. So in which we can see right angle triangles. And let's see another one. Here you can see hanging gardens. This is the one. Here you can see the hanging gardens, the 4th one. So this is also one of the 7 wonders of the ancient world, consisting of a wide variety of plants and shrubs and all. And this resembles a large green mountain. So from these are some of the wonders of the world which shows us the right angle triangle, right? So there is a talk that they have been saying that Indians, Mayans, Egyptians are using right angle triangle. They are using a very interesting concept which is a Pythagorean theorem, which is developed by a famous mathematician, Pythagoras. And he is a great mathematician. This theorem was named after him. So he is actually the one who given a correct proof, that is a geometric proof for this theorem. And you can see the picture of him. He is the Pythagoras, who is a great mathematician from Samos. And here is another one. Not only him, there is another mathematician called Baudhayana. He is from India, had contributed a lot. That means he is the one who had given this theorem in his famous book called Sulba Sutra, in which there will be some axiomatic rules. And there will be no proof for that. And I think only for that he didn't get that much popularity. And let's see another one. He is the Bhaskar Acharya. Here you can see him. So this Bhaskar Acharya is the one who gave the correct proof. He is from India, and we are proud to say that. And this Pythagoras theorem states that in a given right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So, as we know, reason is immortal. So let's have a proof of that, so that you will be having a correct, you will be understanding the concept, and through which let's move to the topic. So here you can see a right angle triangle. Here you can see the right angle triangle, where this is the CD is an altitude for this. That means in this right angle triangle, when we draw an altitude, there forms 2 right angle triangles again. And using similarity, let's do this. This proof was given by Bhaskar Acharya, and let's move into it. So here is the vertex A. Opposite to the vertex A will be A, small a. The length of it is said to be A, and vice versa. And here AD is equal to F and DB is equal to E. So using similarity, let's take the first triangle, triangle ACB. That means this bigger triangle when compared to the smaller triangle, which is triangle DCB, those two are said to be similar. According to the similarity rule, those two are said to be similar according to AA similarity. And if those two are similar according to the similarity, corresponding sides are in the same ratio. So here you can observe. In this bigger triangle, hypotenuse is C by base, which is A. So C by A is equal to in this smaller triangle, you can observe hypotenuse is A and the base is E. So C by A is equal to A by E. When you cross multiply this, we get A square is equal to CE. And this is the first equation. And when we compare this triangle to the bigger triangle, which is triangle ACB, when compared to the triangle ACD, here you can observe hypotenuse, which is C, to the height C by B is equal to. In this triangle, hypotenuse is B and the height is F. So C by B is equal to B by F. So that tends to B square is equal to CF. So when we add these two equations, that is A square plus B square is equal to CE plus EF, and A square plus B square is equal to, when we take C as common, we get E plus F. So A square plus B square, which is equal to C square. So this is about the theorem given by the Bhaskar Acharya. And there are so many, there are about 4,000 years after which there is, people are working on this Pythagoras theorem. And Chinese have contributed a lot. And coming to the next part of it, when we saw the Stonehenges and the other thing, which is pyramids and all, there is a lot more that has to be learned by us by looking at Stonehenge and pyramids through this Pythagoras theorem. So let me draw your attention to the topic given to me today, that is real life uses of Pythagoras theorem. So real life uses of Pythagoras theorem. So I just want to tell you in various fields how it is used. Here you can see Earth is at the center of the circle and Moon is at the point of contact. Let's say Moon is rotating around in a circular path where Earth is taken as center and Sun is at the exterior point of this. So when we draw a tangent from the Sun to this Moon, there forms a tangent and which is perpendicular to the radius. That means, as we know, tangent is always perpendicular to the radius, so there forms 90 degrees, which is a right angle triangle. So here these two triangles are said to be congruent because these two, when we draw tangent from an exterior point, these two tangents will be equal. So there forms two congruent right angle triangle. So that means in cosmology also this is used. To find the distance between two celestial objects, this theorem is used. That means we can, that is of some greater distances. So in space, this is mainly used. So let's move to another slide. Yeah, in here you can see oceanography, right? That means sonars is a technique which is used for navigation, communication, and to detect the presence of submarines in the ocean. So that means when we send, here you can see, when we send sound waves into the ocean, when it strikes the object, it gets reflected back as we know. So when the people receives that echo, then they will be knowing the distance traveled by the sonar, the sound waves. So through the distance, they can find, if they take an altitude, so that they can find the depth at which the submarine is. So like this, in oceanography it is used. That means in defense purpose it is mainly used. We can say that Pythagoras theorem is used for rescue of the people, right? So this is the principle which is used to find the depths of some great barrier reefs and to find the heights and also to find the distances in the oceanography. And the thing is, there is an instrument called sextant. That instrument that means the sextant is an instrument which is used to find angles and all, which is in the oceanography and in navigation. It is mainly used. Those people, and it is also used to find angle between any two celestial objects, like that. So this is about the oceanography. Let's move to another slide. Yeah, in navigation, let's see how it is used in navigation. It is actually used in 2D navigation. That means if you are at sea and you are navigating to a point. So that is 300 meters north and 400 meters west. So by using this theorem, you can find the distance from your ship to that point. So this is the by using this theorem, it is possible to find at longer distances. So this is the principle used in air navigation also. That means pilot can use this by knowing the height from the ground and also the distance from the the destination airport. By using these two, he can measure, he can know from at what point he has to descend from the airport. This is used by like this in air navigation also it is used. So let's see how it is used in construction. Here you can see twin towers, right? They are joined. Here they are joined. And here also you can see right triangles. That means in the construction of this, I think Pythagoras theorem is used, right? That means people said that when there is somewhat calamities occur in this Malaysia, which is in which these are located. So when some calamities occur, like earthquakes, there is these constructions won't get ruined, right? So I think Pythagoras theorem made it possible, right? So I think that might be true. So yeah, here you can see the Eiffel Tower. Here you can observe these points, right? Here you can observe those points where right triangles are used. That means Pythagoras theorem is used at every section of the Eiffel Tower. You can observe right angle triangles. So I think Pythagoras theorem is used in everywhere, at every construction. So let's move to another slide. What is this? Yeah, it's Jantar Mantar, right? Yeah, which is located in India. And the thing is, this is actually an equinoctial sundial. You know what a sundial is, where it consists of a gnomon. Here is the gnomon. Here you can see the gnomon, which is placed at the hypotenuse of a right angle triangle. That means this is also, this is parallel to the Earth's axis. Because Earth's axis is somewhat tilted towards the side, so when it revolves around the sun, there may be somewhat changes in its shadow. So when we place that gnomon on the ground, there will be somewhat changes while it revolves around the sun. So that is why, to avoid that small changes, this gnomon is placed parallel to the Earth's axis. And here you can see the two quadrants which are either side of that gnomon. So when sunshine falls on that hypotenuse, that is gnomon, the shadow cast on this quadrant of the circle. Here the quadrant of the circle. So through which time is known. We can determine time by using the shadow cast on the quadrant. So this instrument is mainly used to find the time at a particular instance. So there are 5 Jantar Mantars in our India, of which the greatest, the famous one is at Jaipur, which is the world's famous Jantar Mantar. So let's move to another one. Here you can see the gate bridge, golden gate bridge. And here also I think Pythagoras theorem is used, because here you can observe right angle triangles. So in this right angle triangle, I think this makes this to get the stability to that construction. At every construction, this hypotenuse is used to support those pillars and all. So that means through which it gets this stability. So in construction works, it is mainly used, I think so. So not in constructing corners of a room also, we'll be using Pythagoras theorem, where 3, 4, 5 triangle is formed, which is a 3, 4, 5 triangle means a right angle triangle. Here we are using the converse of Pythagoras theorem. If it forms 3, 4, 5, which is a Pythagorean triple. What a Pythagorean triple is? Yeah, if that means 3 square plus 4 square, which is equal to 5 square. That means it forms a square plus b square is equal to c square. There are so many Pythagorean triples, like I'll list you something, that is 6, 8, 10, 5, 12, 13. As we have 5, 12, 13 is we saw in Stonehenge, yes, and 7, 21, 25. So these has to be reminded by us, because these are used in so many computations and all. Because in physical science, that means in simple pendulum, let's say, we'll be having some tangential component, radial components and all in physics. So there we'll be using these kind of computations. And in whatnot, when it comes to mathematics, like my subject, which is mathematics, there also we are using, if let's say in mensuration part, I have taken a cone, I need to find the volume of a cone. What are the basic things which I need? I need a radius and the slant height of the cone and height. Slant height can be measured, but what about the height? Can I put any measuring tape where there will be some liquids inside of the cone? Is it possible? It's somewhat difficult task, right? So there I have to use this Pythagoras theorem, where slant height of the cone will be the hypotenuse of the right angle triangle, where we will be drawing an altitude from the base area of it to the tip of that cone. So like this, in mensuration part, not only in that, when comes to vector algebra, to find the position vector, as you all know, which passes through the origin. So to find the magnitude of a vector, we'll be using this theorem. And mainly trigonometry is the thing. Trigonometry is correlated with the Pythagoras theorem. Trigonometry, when it comes to trigonometry, here we'll be showing the relation between angle and side. That means we'll be showing it to a particular right angle triangle. That means Pythagoras theorem is used in trigonometry. So not only in trigonometry, in various fields of mathematics, in calculus also, in differentiation also we'll be using it. So yeah, that comes under mathematics. Now let's move to another slide, an interesting topic now. Yeah, here you can see sports and games. That means in recreation it is used. Like, you know, in football, I'll tell you a trick in football. The players will be playing football, right? So they'll be pushing that ball along the hypotenuse. So that means along the hypotenuse by making 45 degrees angle, so that they'll be getting more score. That means they are pushing that ball along the hypotenuse of a right isosceles triangle. So there Pythagoras theorem is used. And here also you can see in baseball, in rugby, in so many games also they'll be using. And mainly in play fields, that means to measure, you know, there'll be certain distances used in sports. That means to make a ground, there'll be certain distances. There also they'll be using this Pythagoras theorem. And let's move to another slide. Yeah, what you can see a sliding board over here. Actually, sliding board and the staircase, which are at the back, that means flipped 180 degrees. So those two forms just a triangle. It might be an acute angle or it might be an obtuse angle triangle. So we are using Pythagoras theorem. This theorem, that means if we draw poles, that poles makes that stable, right? So when we there'll be some poles which are in between the sliding board and the staircase. So those poles make them stable, and those poles makes that acute angle triangle, which those poles are actually perpendicular to the ground, and they makes two congruent, I mean it might be similar, they make two similar right triangle triangles. So here also this theorem is used in construction of sliding board. And not only in this, in amusement parks, where to get the stability, we'll be using hypotenuse, right? We'll be using some slant height to get the stability. To make it stable, we'll be using those. Like you can see the roller coaster over here. Roller coaster, here you can observe yellow color, right angle triangle. These are also to get the stability, you know. These are used. So mostly in amusement parks, construction of those, engineers will be using it mainly. And that means all this field comes under recreation. So let's move to another slide. So yeah, here you can see the mathematics. Yeah, what the thing, that means Pythagoras, after the discovery of Pythagoras theorem, they came across irrational numbers, because you know, we can show up natural numbers, whole numbers and rational numbers on the number line, but when it comes to irrational numbers, it is impossible, I think. But they made it possible by using this theorem. They took one unit at the x-axis and 1 unit at the y-axis. By using this theorem, we can take root 2, hypotenuse will be root 2. By drawing an arc to it, we can measure, we can show root 2, that means irrational number on the number line. And here we have to again take 1 unit perpendicular to the root 2, so there forms again right angle, and we have to take then the hypotenuse will be according to Pythagoras theorem under root 1 square plus root 2 whole square, which is equal to root 3, and when we draw an arc, then we get again the value of root 3 on the number line. So like this, which it is also used. So my dear friends, in construction of duplex houses, they'll be using some spiral stairs, right? Because if I build inclined stairs, then they need some more space, that requires more space to occupy, and that makes uncomfortable. So they need and spiral stairs, which makes a less area. So there also we are using Pythagoras theorem, right? And here you can see the beauty of mathematics. That means square root spiral shows you the shell. That means it resembles this shell, and the stairs resembles Pythagoras. That means here square root spiral. So here you can see the beauty of mathematics. And yeah, let's move to another slide. Yeah, friends, if I go to purchase a TV, the measurement which I ask them is, I need some 24 inches of TV and I need some 48 inches of TV. That measurement is actually the diagonal of the TV screen. So if I want to know the sides of the rectangular screen, I need to know, because whether it fits in my on my wall. To know that, I need this other two sides of it. So there we'll be using Pythagoras theorem, because as we know, the sides of the TV are in the ratio 3:4. So using this theorem, it is possible to measure the other two sides, and by that I'll be knowing whether it fits in my TV desk or not. So yeah, let's see another one. So yeah, in agriculture process, we are using Pythagoras theorem. That means if I need to know the steepness of the slope of the terrain, there we will be using telescope and also measuring stick. We have to keep the measuring stick over a particular distance, and through the telescope we have to see that measuring stick, and they form angle of depression, as we know, and that comes under trigonometry and all. So here between the angle of sight and the measuring stick make a right angle, and as we know, the measurement of that measuring stick and the distance between that person who is observing and to the measuring stick, obviously I can measure the hypotenuse, which shows us the steepness of that that terrain. That means in terrain farming, that means in agriculture also, we are using Pythagoras theorem. So let's move to another one. Yeah, in painting a wall, this is really a correct example, I think. That means there are so many examples from which I think this is good, because painters will be keeping their this ladder slantly, so they have to keep in such a way that the paint shouldn't tip over. If it get tip over, so there'll be lots of paint get spoiled, right? So in these situations, we are using Pythagoras theorem. So they have to keep in such a way that there'll be no any tip over to the paint. Okay. So let's move to another one. Yeah. Here, in keeping the book slantly, also we are here indirectly we are using Pythagoras theorem. So when I say this, I got a story in my mind, that is about a girl. it's an incident happened to a girl who wanted to take her guitar, which is a beloved object to her. So she wanted to take her guitar with her to the abroad. So at the airport, the security restricted her to not to take more than 4 inches object. But the guitar is of 5 inches. So what she does was, cleverly, she took a carton board where the sides ratios, side is in 3:4 ratio. So she kept that guitar slantly, that means diagonally. So that guitar diagonally, so that she could do it. So she happily, there was a happy end to her, that she could take it with her. So let's see, let's summarize the topic, what we have learned till now. Here you can see in agriculture, like in terrain farming, we used Pythagoras theorem, and in cosmology it is used to find the distance between two, to find the distance between any two celestial bodies in the space, and in navigation mainly it is used. And here we also discussed about the sextant, which is most far older object. And then we used construction. Mainly in construction they have used, and in recreation, that means in sports and games, to measure the distance between any two points in the playground, they are using to determine the poles. And in surveying, here surveying is actually a process where cartographers will be using this to measure the numerical distances between any two points before creating a map. And here you can see beautification, and like in square root spiral, how they have used, we have already seen. So in various cases we are using Pythagoras theorem. And not only in this, if I want to place my pen in my purse, that means I have to place it slantly. If it is longer than my purse, I have to place it slantly so that it fits in my purse. So that there forms some triples, Pythagorean triples, as we have discussed before. So there we are using Pythagoras theorem, knowingly or unknowingly. That in another, that means masons will be using Pythagoras theorem to construct windows and all. Firstly, they will be taking the diagonals, right? So there we are using. Where not, everyone, knowingly or unknowingly, we are using Pythagoras theorem. So here in this day, today, I have told you various instances at which Pythagoras theorem is used. And now I leave it to you. So you have to think over it, and you have to use this theorem in everyday life, and you have to think of it at different areas, how we use this Pythagoras theorem. And that's it. Before ending my topic, I just want to thank our secretary, R.S. Praveen sir, to make this session possible, and the others. Other crew who is behind this. Thank you.